Hello student, welcome to our second lesson. We are going to look at Newton's second law of motion. Now we start with the definition or statement of the law. Now this one states that the rate of change of momentum of a body is directly proportional to the resultant external force producing the change and takes place in the direction of the force. So the rate of change of momentum of a body is directly proportional to the resultant external force producing it, and it takes place in the direction of the force. So mathematically, we say that the resultant force acting is directly proportional to the rate of change of momentum. From there, we look at the relationship between force, mass, and acceleration. Consider a force F that is acting on a body of mass m for a time t. If its velocity changes from u, where u is the initial velocity, to v, where v is the final velocity, then we can say that the change in momentum is equals to the final momentum minus the initial momentum. And we have seen that from the definition of momentum is given by mv. So when we talk of the final momentum, we take the mass and then we multiply by the final velocity. Therefore, we have that the change in momentum is mv, then minus the initial momentum, which is mu. So the change in momentum is mv minus mu. When we come to the rate of change, whenever we see the word rate, you should have that we are considering the time. So the rate of change of momentum will be the change in momentum divided by the time. And the change in momentum is mv minus mu, you divide by time. You get that it is mv minus mu over t. From the Newton's second law, we have seen that the resultant force is directly proportional to the rate of change of momentum. And the rate of change in momentum is this one, mv minus mu over t. From here, we can factor out m, and by so doing, we are left with v minus u over t that are inside the bracket. If you look at this term, it is the change in velocity over time, or the rate of change in velocity. And this change in velocity with the time is what we call the acceleration. So we can replace the term inside the bracket with a, which gives us that F is directly proportional to ma. That is, the external or the resultant force is directly proportional to the mass multiplied by the acceleration. So if F, in other words, if you replace the sign of proportionality with an equal sign and a constant, you get that F is equals to kma, where k is the constant of proportionality. When F is equals to 1 Newton, A will be 1 meters per second squared, m will be 1 kg, and if that is the case, then k will be 1, and therefore F is equals to ma. This is the expression of Newton's second law. Remember the way we have derived F is equals to ma. In other words, if you have the mass and the acceleration, you can be able to get the resultant force acting on a body. From there, we move to the definition of a Newton as per Newton's second law of motion. We have seen that a Newton is the force which produces an acceleration of 1 meters per second squared when it acts on a body of mass 1 kg. And that is why, through this definition, we are able to get the value of k as 1. And if the value of k, that is the constant of proportionality, if it is 1, then we are deriving our equation F is equals to ma. We look at several examples. We start with the first one. What force is needed to stop a 500 kg car moving at a velocity of 180 km per hour in 12.5 meters? We proceed as follows. M is equals to 500 kg. V, that is the final velocity, because we want to stop the car, the final velocity will be 0 meters per second. So we proceed as follows. Our U is equals to 180, that is, in other words, we want to convert this into meters per second. 180, we multiply by 1,000 to convert 180 kilometers into meters, and we divide by 3600, that is, this is 1 hour in terms of second. So when you do that, you get that your U is 50 meters per second. Our displacement, or our distance, is 12.5 meters. So what is the force? From the equation, this is the equation, the third linear equation. V squared is equals to U squared plus 2AS. From this equation, we can be able to get A as V squared minus U squared divided by 2S. Remember, we have made A as the subject of the formula. So we have taken U on this side and then we have divided by 2S. By so doing and by substituting the values, we have that V is 0 because the body is coming to rest. Then U is 50. Then our S is 12.5. So when you put all the values here, we have 0 squared minus 50 squared. You get negative. We are getting the negative. Then when you divide by this, you get that it is A is negative 100 meters per second. From Newton's second law, we have seen that F is equals to ma. So our F will be 500 multiplied by negative 100. You get that it is negative 50,000 Newton. Remember, this one is negative, which implies that the body is coming to rest. Then example number 2, an external force applied to a ball of mass 160 gram increases its velocity from 2.5 centimeter per second to 275 centimeters per second in 10 seconds. Calculate the force applied. We have the mass 160 G. In other words, we can be able to get, this is 160 grams. We can change this into kilogram by dividing through by 1,000. You get that it is 0.160 kilogram. Then you are given the velocity in terms of centimeter per second. So you can convert this by dividing with 100. You get that it is 0.025 meters per second. Again, the final velocity is 2.75 meters per second. So we want to get the value of F. So F is equals to ma. Or F is equals to m into bracket V minus U over T. Because this term, V minus U over T, is our acceleration. So when you substitute the values, you have that it will be 2.75, that is our final velocity, minus our initial velocity, 0.025, divided by 10, which is our time, this one, 10 seconds, and then you multiply by mass, which is 0.16. When you do that, you key all these values inside your calculator, you find that the force will be 0.0436 newtons. From there, we move to another term, impulse. Now, this one is defined as the product of force acting on a body and the time in which the force acts. In other words, impulse is force multiplied by time. Then when we come to the impulsive force, this refers to the force which acts on a body for a very short time during collision. So, if the force F acts on a body of mass m for a time t, then the impulse is given by F times t, that is force times t. You get that the impulse is Ft. From here, we can be able to get the SI unit of impulse. Because we are multiplying force which is in Newton and time which is in second, then the SI unit of impulse is Newton second. But we know that from Newton's second law of motion, F is equals to the rate of change in momentum. That is, F is equals to mv minus mu divided by t. If you multiply through by t, you'll find that this side you will multiply by t to get ft, and then this side, this t will cancel out. You are left with mv minus mu. So we can say that ft is equals to mv minus mu. But we know that ft is the impulse. Therefore, mv minus mu is the change in momentum, is also impulse. So we can say that impulse is also the change in momentum. Now, this implies that the impulse of a force acting on a body during some time interval is equal to the change in momentum produced in that body in that time. Therefore, another unit of momentum is Newton second. And since the rate of change in momentum is given by this value, that is Ft is equals to rate of change, this one is change in momentum, therefore F is the rate of change in momentum. That is the force F is change in momentum divided by T. So we can define the force as the rate of change in momentum. So the area under the plot of force F against time T represents the impulse or change in momentum during the collision. Now, if you look at this diagram or this graph, if you are plotting force against time, the area under the curve will be force times time, and therefore the area under the curve or the area under the plot will give us the impulse or what we call the change in momentum. Then from there, note that the impulse occurs between bodies that are colliding, and the impulsive force is very great and it can cause destruction. That is why you see if a car collides with another, that car is destroyed because of that impulsive force. And the time for which this impulse acts determines the extent of damage. For example, if the time of impact is long, the damage will be less. But if the time of impact is short, the damage will be more. That is, the following are some examples of designs which are made to prolong the time of impact and therefore reduce the damage by impulsive force. So in other words, we are saying if you want to reduce or to prevent or to decrease the damage that is caused by impulsive force, you have to prolong the time of impact. And we have that the eggs are packed in spongy crates so that even when they are vibrating, then the collision between the crate and the eggs will be prolonged because the crates are spongy. That with the impact or the damage is reduced. Then you have that the smartphones are put in soft holders so that if the smartphone falls, then the impact between the floor will be prolonged because of these soft holders. That way the damage is reduced. Then we have that the vehicles are fitted with safety airbags so that now when you collide with another vehicle, these safety airbags will help you to prolong the time of impact, and that way you reduce the damage. Then some vehicles have collapsible bumpers and steering so that now when you collide with another one, then this one, because they are able to collapse, they will reduce or they will prolong the time of impact, and that way the damage is reduced. Also, we have that the higher jumpers, they usually land on soft ground. The soft ground will ensure that they prolong the time of impact and therefore they prevent that damage or that impulsive damage. Then from there we look at examples. Determine the change in momentum produced when a force of 4,000 Newton acts on a body which is at rest for 0.03 minutes. We proceed as follows. F is 400 Newton. Then the time is 0.003 minutes, which is equivalent to 0.18 seconds. The impulse is equal to change in momentum, which is the same as Ft. Then the change in momentum will be F, which is 4,000 Newton, multiplied by time, which is 0.18 seconds. And when you multiply, you get that the change in momentum will be 720 kilogram meter per second or 720 Newton second. Then we move to another example. A force of 200 Newton acts for 5 seconds on an object of mass 40 kg. What is the momentum change per second? Find the impulse. Determine the change in velocity. We proceed as follows. The change of momentum per second is force. Remember, we have seen that force is defined as the rate of change in momentum. So when you talk of the change of momentum per second, you are referring to the force, and the force is given as 200 Newton. Then part B, find the impulse. Our impulse is Ft. F is 200 Newton multiplied by 5 seconds. You get that the impulse is 1000 Newton second. Then number 3, we have the change in velocity. The change in velocity will be given by the change of momentum divided by mass. So you get 1000 Newton second divided by 40. You get that it is 25 meters per second. That is the change in velocity. Then question number 3. Determine the change in velocity produced when a force of 2.5 times 10 to the power 3 acts on a body which is at rest, and the time that it takes is 0.02 seconds. Then part B, what velocity will be given to the body if it has a mass of 20 kg? We proceed as follows. The impulse is defined as the change in momentum, but the change in momentum therefore is Ft. Your F is given by 2.5 times 10 to the power 3, and the time is 0.02 seconds. So by multiplying, you get that the change in momentum is 50 Newton second. Then part B, what velocity will be given to the body if it has a mass of 20 kg? So we substitute in our equation here, Ft is equals to mv minus mu. And remember, the body was at rest, therefore our u is 0 meters per second. Therefore our Ft, because this will go, because u is 0, our Ft will be mv. So you get that v will be Ft divided by mass. So it will be 50 Newton second divided by mass, which is 20. And by dividing, you get that the velocity, or the final velocity, will be 2.5 meters per second. Then from there we have the assignment again. The assignment is testing what we have just covered. So make sure that you are able to revise before you attempt the assignment. So thank you, and let us meet in our next lesson.